4 rules for drawing the ray diagram was completed, and these ray diagrams were over. Just tell me one thing, class, could you note also? Could you write everything, or was something left to be written? Have you noted?
Yes, ma'am.
Yes,
Oh,
ma'am.
all right. So let us just see the convex one and let's move forward and complete this reflection part, because you have, apart from the mirrors, you have the plane mirror also. Plane mirror is also there, and recently a question also has come from it. Convex mirror is the easiest. Convex lens are important and lengthy. Concave lens is the easiest, and just the opposite is there in the case of the mirrors. Convex mirror is easiest, and concave mirrors have lots of cases. Because here the reason is that, see, if I have a, let's say I have a mirror. This is a convex mirror. This part is available for the right light ray to occur. Now this is the part of the mirror where the center of curvature and all are not lying. Center of curvature, radius of curvature, anything will be lying in this part, but that is not under consideration because this part is being silvered. So where will you put the object? Object will be put in front of it only. Here only you will put the object. So if you are putting the object in front of the mirror, there is no point of reference. Center of curvature, that is lying behind. The focus, that is lying behind. So you actually don't have any reference point. So you just put it anywhere in front of the mirror. That's why we just have single case. You are putting the object in front of the mirror. Definitely the sizes will range when the object will come closer to the mirror or far away from the mirror and all, but that's a different case. That is just a small variation. Ultimately, you need to remember one thing. See, the ray of light is parallel and passes through the focus. That's what we've studied. But this is a convex mirror. In convex mirror, the light cannot pass through this, means it cannot pass through the silvered portion. That will be refraction, that won't be a reflection. So how we'll say the light ray has reflected? The light ray will be reflected. You produce it and see it, is it passing through the focus or not. That's why in case of convex mirror, you obtain virtual images. Like this is one ray. Similarly, the center of curvature also, this will be retraced. But how will you know what is happening behind the mirror? See, behind the mirror, the light ray is getting intersected is not a real concept. So you produce the light rays and then you see where are the light rays actually getting intersected. Then it can be at any point. If you bring it closer, it will be closer. If you bring it far away, it will also shift. But you just have one single case, and what is that? Your object is put in front of the mirror. We just say in front of the mirror because you don't have any reference point. Okay, so in front of the mirror, image will be formed behind the mirror. Don't write reference point because you don't know where will it form. It can form anywhere behind the mirror. For convex and convex, diagrams also usually not come class. I haven't seen any question till now where the ray diagram of convex mirror has come yet in your board exams at least. So this is behind the mirror. From the concave, it can come. Usually that is also not very important, but that can come. Convex is less important, but anyways, TAS is a very one easy single case, so you can revise it before the exam. Now, size, what can you see about the size class? What can you say? Look, tell me. Look, compare the object and image. Class, whether it's whatever kind of image has been formed, tell me. This is your object here, AB. Yeah.
Virtual and erect.
It is virtual and erect. That is completely correct, Janak, but that is the nature. You're right. You have told me the next point. I was asking about the size, but he is right. This is virtual because the actual rays are not meeting. So virtual. And definitely this is not inverted. We can see it clearly from the picture. This is erect. What can you all say about the size of the image? Compare it with the object and then answer. Yes, Aisha. Aisha, answer.
Diminished.
Yes, diminished. If you all know, why don't you answer then? Correct, Aisha. See, you can clearly see object is greater, image is formed lesser, so this is diminished. Okay, this is it, what you need to remember. Now we'll see one or two derivations that come in the exam a lot. Derivations come from this chapter a lot. Write down this case, then let's see. Right. Let me know once done.
Done, ma'am.
Others also? Everybody? Everyone has done?
Yes, ma'am.
Okay. See, next is a relationship between the focus and the radius of curvature. For 2 marks, I have seen this question coming, not more than that. But this relationship is used in the numericals also. And the relation is very easy anyways. You will remember it in any case. But derivation is also simple, but this has come for 2 marks in the exam. Now, yeah, this point that I have written on this purple in the upper right corner is basically whenever you want to drop a normal, for a plain flat surface, you will drop the normal like this, perpendicular to the surface, the way we have been taking it for magnetic flux, electric flux. So you already know that part. But just when we talk about the curved mirrors, now mirrors are curved. So dropping a perpendicular becomes difficult. What you do, you just join from that point. Let's say I want to find out for this point. This is a curved mirror and I want to find out for this point. Wherever its center of curvature is lying, just join a line. That will naturally become its normal. Means this is how we take out the normal for the mirror. That's what has been written here. That normal means perpendicular to the surface. So join the point on the mirror to the center of the curvature. This is how you will get it. Anyways, see, this is a concave mirror present. Incident ray of light is there where it is coming from infinity, and when the light ray, when your object is at infinity, image is formed at the focus. Object at the focus, image at infinity. This is what we studied in the rules also, if you remember the 4 rules that we studied. Now see, incident ray is parallel to the principal axis and the light ray passes through the focus. This one is the dotted one, but this is just the normal that we have plotted. Now see, if this is the incident ray, the line passing through the center of curvature is normal. Now pay attention and tell me one thing. If this is the incident ray, this is the normal. What is this?
Angle of incidence.
Very good, Zainab. This is the angle of incidence. Yes. If this is the angle of incidence, this should be.
Angle of reflection.
Yes, correct. Very good. This is angle of reflection. Now, class, what we do, see, in derivations, we need to have many triangles, we need to have many angles, especially for ray optics, because this is a chapter which is based on the movement of light rays. So we cannot put any other factor here except the light rays. So what we'll do, we'll just put random angles also at many places. Here I am taking this as some alpha. Let me take it as some alpha. Yes, Jesleen, can you tell me the first law of reflection that can be valid here? Yes, Jesleen. Law of reflection.
Sorry, ma'am.
Yes, Jesleen, say which 2 laws only which one is valid here? Actually, both the laws are valid, but tell me one which you can clearly see from the figure.
Angle of incidence is equal to angle
Yes,
of reflection.
perfect. Very good. Angle of incidence is equal to angle of reflection. So I can say angle I is equal to angle R. Now look class, this is angle R. Okay. Now angle I and alpha, they'll be equal because these are what kind of angles? Alternate angles. See, this is equal, as Jesleen said, angle I is equal to R. This is valid because of the laws of reflection. This is valid due to the laws of reflection. So angle I is equal to alpha because they are alternate angles. Okay, now look, I is equal to R, I is equal to alpha. So I shall say alpha is equal to angle R. This angle alpha will therefore be equal to angle R. Plus, if this is the case, can you tell me what sort of triangle is formed here, BCF? Hmm? What kind of triangle is this triangle BCF?
Right angle triangle.
Not right. Where 90 degrees formed? Using this concept, focus on this. Alpha is equal to R. It's triangle. Isosceles triangle. The opposite angles are equal in the isosceles only, no? Opposite angles are equal and opposite sides are also equal. So if two angles are equal, these sides will also be equal. I can say CF is equal to FP. So CF is equal to FP because this is forming isosceles. Yes, see, Zainab, I was saying if two angles are equal, look, here the triangle that has been formed is this. This triangle that I'm referring to, this one. So this triangle is equal to, look, this is angle R, this is angle alpha. So if these two angles are equal, the opposite sides will also be equal. Is it?
Yes, ma'am.
So I can say these 2 points will be equal to, this is B point, this is C point, this is F point. So I can say CF is equal to FB. Now look, one more thing. The mirror's aperture is very small. The mirror's aperture is very small. So F and P are not at a very huge gap to each other. Okay. So instead of FB, you can, sorry, not F, B and P. Aperture is not a very curved, big, sharp mirror. So B point and P point, they are very close to each other. It means you can equate them. You can reverse them. So instead of FB, I can use FP. Remember, FB is almost equal to FP because of the small aperture. So I can say, if I can replace this FB with FP, I can say CF is equal to FP. Are you getting it? This side, these two sides are equal. This is equal to this. But we can say this is equal to this also because the aperture is small. The points are located very close to each other. So in short, this will be equal to this also. A is equal to B, A is equal to C. So B and C are equal. So this is the logic that will be applied. Now look, this complete is what? This is the radius of curvature from the pole to the center. And what is this till F point? That's the focal. So what can we say here? From here we can say this CF plus FP is equal to radius of curvature. They are exactly the same. 2 of FP is equal to R. 2 of focus is equal to R. Focus is R by 2. Remember, focal will be lying at the half of the radius of curvature. Am I clear to everyone in this?
Yes, ma'am.
Yes, ma'am.
Okay, Jesleen, got it? Write it down, class. Class done?
Yes, ma'am.
Okay, now this formula, mirror formula, you must have done it in the lower classes as well. 1 by f is equal to 1 by v plus 1 by u. That was there in your 10th classes NCRT also. That is there. So still we will have to do it here. And questions, the level of difficulty will be increasing because you will have combinations of mirrors together. So those questions can be a little tough, and that's the same thing which will happen with the lens. Now see here, this is the object which is put. Now understand the ray diagram we have drawn it in advance for all of these because this takes a very long time to draw and make the rays collide here without the scale on the screen. But as I've told you in the last class also, everybody please sit with the scales. And in the exam, at least take the protractor for the mirrors as well as for the lens and draw proper uh, these neat ray diagrams, especially those who do not have a good handwriting and their work is messy. Because here in the ray diagrams, you will have trouble if the image is not very clear. If it's not very clearly obtained, then this will be a big trouble here. Okay, see, this is the object present able. Now, first ray, this is the incident ray class. The first ray, which is parallel to the principal axis, passes through the focus. Second ray passes through the center of curvature. Lines have intersected here, till here only. Image is formed. But we are using the third rule also because we have to derive. And by just avoiding this, we'll be limited of the triangle. For the derivation, we need more triangles. That's why we are using it. For every figure, don't do this. The way we have drawn the ray diagrams previously will be applied here as well. Like this 1 and 2. That is sufficient for the image to be created. You just need an intersection. The third one we are using, the third rule, so that we can obtain more number of triangles. That's all. Okay, this is just for the derivation. So this ray of light touches the pole, and as I told you, when the ray of light touches the pole, it follows the laws of reflection, law of reflection, or in fact laws of reflection. Both are followed, and the ray of light is reflected. So all the three rays intersect, and here an image is formed. Now let's apply the sign convention. See, from B point to this P point. हाँ देखो, from this B point to this P point, everything is measured with respect to the pole of the mirror class. So from the pole, move to the object. That is known as the object distance. Wherever your object is put, this is the object distance, U. Now, as per our sign convention, U will be negative because it is put in front of the mirror. Okay, in this case. That is image distance. The image is formed here, B dash. B dash P is the image distance with respect to the pole. ये मत सोचना कि मिरर के पीछे जा रहा है. This is exactly at the pole of the mirror class. Okay, this one is the pole of the mirror. This is the image distance B. Since here in this case image is formed in front of the mirror only, image distance will also be negative. That is minus. P will be the focal length and CP will be the radius of curvature. From the pole, everything is with reference to the pole. Please do not be confused with these arrows. These are not going behind the mirror. But right now, everything is formed in front of the mirror, so everything will be negative. V, F, U, R. Before I begin the derivation, tell me till here, have you all understood everything? Or should I repeat anything? Clear?
Yes, ma'am.
Okay. Now, see, look at here, similarities of triangle. Do you remember? Class 10th में तो पढ़ा होगा. Similarities of triangle, and those who have mathematics with them, they must be knowing. When two triangles are similar, the side angle side SS property, side property, angle side angle property, and all we say triangles are similar. So here, most of the derivations of the ray optics will be solved using the concept of this similarity of triangles. Okay. So look at this. I'll mark it. Just look at this triangle. A, B, C. This one. This triangle. Okay. A, B, C. And then we'll see the smaller triangle A dash, B dash, C dash. This one. That's why we have used so many lines so that we can form many triangles. One bigger one will also be used, and you will realize why have we taken the third property as well in this. So this is one triangle over this side. This is another triangle over this side. Now look, this is the common side between them, and these are vertically opposite angles. So using side angle property, these two triangles are similar. I hope you know similar and equal are not the same. They are similar, they are not equal. Obviously, they can't be equal. Nothing is equal here, but since this is the same common side between them, and these two angles are opposite, so we take this as the common uh, triangle. Now, one thing those who do not know or have forgotten, here when you take this, AB is there, A dash, B dash is there. So when you divide these two, they will be equal to these two's ratio, or A dash C and AC's ratio. Means two similar sides will come in the denominators and numerators. Like if I take AB from here, I can take A dash B dash in the denominator. If I take BC from here, which is the similar one to this, CB dash. If I take AC, then CA dash. Like this. Got these are three sides, and this is how we have it. So can I say A dash B dash by AB? See, I hope you're getting my point. Numerator by denominator is there. Numerator, denominator. Numerator from one triangle, denominator from the second triangle. But the ones which are similar, those only are considered. The ones which are similar, those are only considered. Means AB will be corresponding to A dash B dash. So you can take their ratios equal to their ratios equal to these two ratios. This is what we use in the similarity of triangles. So I can say A dash B dash by AB, A dash B dash by AB is equal to B dash C by BC. Now look, this much till this point, CB dash by BC, this much. Is this clear to everyone? The similarity concept?
Yes, ma'am.
Okay. Now look, I can say CB dash. From here we can say this CB dash. CB dash, the smaller one. This, how can we write this? If I want to write this with reference to the pole. Because now see, CB dash is nothing. If you see from the figure, it is neither matching with V, F, nor R or U or anything. So we'll have to write it in terms of those things which are clearly visible to us from these four. Otherwise, how will you perform the derivation? What will you derive? So what we'll do, B dash C has to be written in terms of something known to us. Look class, can it be written as the radius of curvature minus the image distance? Look, if I say here, this is, look here, this is R. Look class, this is R, the complete radius of curvature. And this is the image distance. If I subtract, I'll get this B dash C. Do you agree? All of you. This part, leftover part. Will it be CP minus B dash P? Can I say is equal to B dash C?
Yes, ma'am.
Yes, ma'am.
So that can be written for B dash C. Okay. And for the denominator BC, look, it can be written from U, this image distance U. If from this is U, I want to write BC. This is complete as this is complete as the U. I want to write the smaller part BC. So this is U minus R will give me this part. So those have been written only. In terms of CB dash is written as CP minus B dash P. BC is written as BP minus CP. CP minus B dash P. BP minus this CP will give me all these things. And this is in terms of something known. These are the values that we discussed. It's just that we need to put up the sign convention. So minus R minus minus V divided by minus U minus of R. We can say this will be equal to minus minus plus. So V minus R minus minus plus. So R minus. Till here for this triangle, am I clear to everyone? Huh?
Yes, ma'am.
Others also? Only when Muniba is responding.
Yes, ma'am.
Okay, Aisha, Marwa, Muniba. What about Zainab,
Yes, ma'am.
Jasleen?
Yes,
Understood?
ma'am. Yes, ma'am.
Okay. Let's come to the other two triangles. The ones which I told you, the ones which we'll be taking. This ABP and the smaller one A dash B dash. Look, now this will be a little easy for you to comprehend. This one, this, and this one. They are similar. How? This is the common side, 1 point. So side is there. Apart from it, this angle will be equal to this angle. If you do not have the vertically opposite angles case, you have the laws of reflection all obeying. So angle I is equal to angle R. If I is equal to R, again angle side property, triangles are equal. You can say A dash B dash by AB is equal to B dash P by BP using this. This is more important because the same equation from here will be used in magnification also, this one. But anyways, let's see what is B dash P. Minus V, BP is minus U. This is equal to V by U. So A dash B dash by AB is equal to V by U. And A dash B dash by AB is equal to this, V minus R by R minus U. I can say V minus R by R minus U is equal to V by U. Let me take the cross product. This will be UV minus UR is equal to VR minus UV. So UV, UV, we can bring that together. This will be UV plus UV, VR plus UR. This makes it 2UV is equal to VR plus UR. What we'll obtain? What is the equation? 2UV is equal to VR plus UR. Let's divide it by 2UVR. UVR. Am I audible now? Is it fine?
Yeah, ma'am. Now it's okay. Before it was lacking.
In between the voice is breaking, no? Zainab texted. Others also, I think. Now is it better? Are you able to hear my words properly?
Yes, ma'am.
Zainab,
Yes,
Aisha, and
ma'am.
all. Okay. Divide this by UVR, I'm saying. So you will get UV will be cancelled. VR will be cancelled. UR will be cancelled. What will we be left with? 2 by R is equal to 1 by U plus 1 by V. Plus focal length is R by 2. So 2 by R will be 1 by F. Derived? 1 by F is equal to 1 by V plus 1 by U. Now remember, you have to put in the sign convention for this. Use sign conventions in the mirror formula. This formula is known as the mirror formula. F is the focus, V is the image distance, U is the object distance. Got it, all of you, this derivation?
Yes, ma'am.
Okay. Write it if at any step, if you face trouble, please let me know. Let us try to complete this topic today. Please write it from your class.
Can you scroll up? Done.
Is it completed till here? Sign conventions?
Yes, ma'am.
Yes,
Okay.
ma'am.
See from the equation, this equation, a dash b dash by ab. If we use this equation, look, what is linear magnification equal to? Magnification is actually the ratio of the height of the image by the height of the object. So this is the height of the image and this is the height of the object. Height of the image and height of the object. Now see, a dash b dash by ab. A dash b dash is what? A dash b dash is the height of the image. And I have told you, you always have to take everything with reference to the principal axis. So a dash b dash from the principal axis, this will be taken. And see, when we did the sign conventions, I told you if anything goes beyond the principal axis, below the principal axis rather, this is taken as negative. And when you take it above the principal axis, so that will be positive. This is one of the sign conventions that we already studied. So AB is equal to height of object, A dash B dash is the height of image. And this A dash B dash is equal to V by U from here, right? So we can say this is equal to H minus HI by AB is plus H naught. We can basically say magnification is equal to negative of height of image because of the sign convention by height of object is equal to minus V by minus U. Minus minus sign will be cancelled, but from here minus will be left. Height of image by height of object is minus V by U. So this is the magnification. So what is magnification? Ratio of the height of object, image to the height of object. This is known as linear magnification. You have transverse magnification also. where you calculate the length of the image. Rather than the height, you take the length of the image by length of object. Here, length is considered, okay? And this is denoted by the symbol M. Two more things are here that I'll tell you what we do using the magnification that I'll tell later. First, write down the derivation of it. And remember class, if the linear magnification comes directly, don't start like this, triangle APV. What is triangle APV? You'll have to draw the diagram that we did above. Okay, because this was in continuation, I didn't draw, but you have to draw the diagram also. So just mention it somewhere that you need to draw the diagram. How can you just say APB and E dash, P dash, P dash? Okay. Is the linear magnification clear? Minus V by U.
Yes, ma'am.
Please copy it.